So moving on to Solana, the links will be shared in the chat or in the Central Code socials. So moving on to Solana, we have been doing a few Rust basics because Solana is a chain that is built on top of Rust. Recently, we've been looking at what we need to know before we start building on Solana with their framework called Anchor. And yes, I feel like we've covered most of the most important stuff that we need to know before we start building on Solana. So the rest of the basics, the rest of the features are those that we'll try to cover them as we go through the whole. In Solana, everything is an account. When you create a wallet and you put some money in your Solana in your Solana wallet, it is an account.
Is it me?
Yes.
As if I'm not seeing your screen, I have been off, but is your screen still being shared?
Yes, let me check and see. Oh,
because I've been off due to network issues. Maybe it's my end that is. Yes.
Actually, you're not alone. I've seen a screen. I think
you killed it when you went off.
Okay.
How about there?
Yes. Thank you.
I think you killed it when you went off. You are our father.
Okay.
Yes. So I was talking about how Solana does its things. Everything in Solana is a program. Sorry, everything is in Solana is an account. And everything, the state management, the account, and everything is an account in Solana. Like I was talking about how you can have a wallet and you have money in your Solana account. It is all treated as an account. When you come back to and refer to maybe an application that is built on Solana, what they call as programs, it is an account with some extra few things added to it. For example, there are two different types of accounts. There are accounts that are just readable and they are not meant to change the state of the blockchain, which is what your wallet does. But a program or what you call a smart contract in other EVM chains, it is like an executable. It's going to do some sort of state management on the blockchain. It's going to write some values, it's going to change some values, it's going to update some of them, and it's going to delete some information. So it is marked as an executable, but still it is an account. So like I said, everything is an account with some having a few functionalities added on top of that. So I'll go ahead and try to open my good freeform app, and maybe I'll try to show a few visualizations as we go ahead and see, because I'm more of a visual guy and I like to have these visuals with me. Okay, so after getting that ready, like I've said, maybe to visualize what I've been explaining, if you have a program here, we have an account. Maybe I'll call this account. This is not what I wanted text. So this is an account. In a Solana, maybe you have an application. It will be hosted by this large account, and then within this account you can have smaller accounts. If I know how to change the color. I love this app, but I never take time to understand how it works. That's the funny part. So you can have smaller accounts. For example, if you think of Twitter, if Twitter was built on top of Solana, it will be a giant account with small Twitter accounts living inside this big account. Maybe you have a Twitter account, maybe you have a user's account, maybe these Twitter accounts will be owned by this user's account. Hopefully it can be inside here. Maybe let me try to make this bigger. So this one is the users. This is the user's account. Inside the user's account you can have another. Let me try to find a different one. Inside the user's account you can find the tweet account, like this. So we have the tweet, and hopefully, so okay. So the tweet is inside here, and they are all living in this giant, big account. So what this may be your Twitter. This may be your Twitter or your program. So usually people call them programs in Solana, but it's just a big account having other accounts that are embedded inside them. And you will see how it reflects in the development side, because we'll build these small blocks inside the program, and I think you guys will see how it makes sense, because you have the Twitter account, you have the users account, and then you have the big account. Yes. So and looking at that, we are going to putting that outside. I think looking through my notes. So yeah, so the tooling that we are going to use, I try to make this very simple for anyone, that it won't require big specs, it won't require to have some sort of operating system, and just to get everybody on the same page as us. The tooling is very simple. You do not need to download anything. If you want, and you want to do it locally, you are free to do that. You can go to the Anchor documentation, and it will take you through what you have to install. Like you have to install Rust, and then after installing Rust, then you can install Cargo, and then after installing Cargo, you'll have to have Anchor installed. Yeah, but this can take a very long time, and it has different types. Different ways you have to address that. And I thought that it would be easier if we do it in the browser. So if you go to if you type Solana playground, most of these good chains, they give you a small playground in the browser where you can write your code and you can test everything from there. So it's what I want you guys to use, just to keep us on the same page, so that we do not have to go and test tokens and go through all of that. So when you go to beta.solpg.io, you can find this program, this IDE, where you can write your Solana code, and this is where we are going to do our code and development from the most part. So I think I'll try to increase the font size here, and just to make this maybe full screen. And yes. So talking about, maybe let me go back to this. So talking about the program. So the moment you write some state and put it on the blockchain, there are things that you need to take care of. For example, because writing and changing state on the blockchain requires some sort of execution, and someone has to pay for it. So in EVM chains, if you guys have tried to develop on Ethereum and other chains, you find that sometimes you have to sign a transaction and pay some gas fees, and then maybe you have to sign some sort of payment for you to do some state changes, depending on how the smart contract is built. Solana has something called rent. So the way rent does is the same way as you know about rent. Someone saying something?
No, let me try to mute him.
Okay. So the way you think about how rent works is the same way as Solana rent works. So when you build a program and you put it on the Solana blockchain, you have to put some sort of money. So you have to put money into that program, and every time and then the blockchain will always come and collect rent, some sort of rent, so that your program can stay on chain. The moment the program runs out of money, or you put very little money, then your program will be deleted forever. So when I learned that, I was very, very worried, and I was like, hey, if my program is going to run out of money, then what's the point? Because if I'm playing around with an application and it doesn't have users, then I'm going to be charged. So it was very funny. But now they came up with a solution where you can build what they call rent exempt programs. So what rent exempt programs are is you develop an application and then you put enough money into that account that allows it to live for longer than 2 years. It's like renting a house and then you pay the landlord. Maybe the landlord has an account and says you pay to this account. So you pay for rent that covers beyond 2 years, for at least 2 years. So you put that money there. And the cool thing about having a rent exempt account is the moment you throw that money there, the landlord will never come and collect it. It will always stay there. It will stay rent exempt. So you'll be sleeping for free without getting charged. And the cool thing about it, the money will always stay there. And when you come back and remove that contract, that rent money that you put in that account will come back to you without being taxed. So you've created a rent exempt account, and it has always stayed there. So because you're going to see where rent will come through, it is something that you need to keep tabs on that. And yes, so maybe to show you how rent works. So going back to the playground, we are going to I wanted to first build a certain Hello World project so that I show you how the functionality works. I thought just to get your feet wet, but I thought it would take some time just to log over my program and take us beyond. So I think it's okay. We can just dive right in and build what we wanted to build.
Excuse
me. So for the people that are, yeah.
Gordon is raising up his hand. I don't know whether it's allowed for him to talk or we talk at the end. I think.
Okay. It's okay. I think we can catch the question.
My question was, like, you say that if like you're paying rent and you stop, your program will be deleted. But again, I remember when we met, we were like no one can delete anything written on blockchain. So how will they delete it? And maybe do they just deactivate it, or like what do they do?
Yes, actually that is a very good question that I had when I first stumbled upon this. So it will not be deleted. It will not be deleted, but it will be hidden from view. For example, when you are writing the smart contract, and maybe think of how you may decode the information so that it can be human readable. So that access will be blocked from you, so that the access to be readed and play around with it and executed will be blocked. It won't be deleted from the blockchain, but that access will be blocked. I don't know if that makes sense.
Yeah.
Okay, if we do not have any questions, I hope we could just kickstart and move on. So for the people that are in the playground, you can go and maybe create an account. Press the create account. You can use native Rust. You can build using Anchor, which we are going to use. You can use CPython for the Python people that want to play around with Python, but this time we're going to use Rust. So moving on with our examples that we had in the Rust basics, we are going to continue with the heroes, our superheroes program. So create a program and I'll call it heroes. I think it's the spelling, select anchor, and then select create. So what this one does, it's going to put you on DevNet. It's going to have a small wallet for you. So if your wallet does not have Sol, you can go and type Solana faucet here, and there is this airdrop Sol. You can go to the Solana DevNet airdrop Sol and copy the address. So here you can come here, and I think here it's copy the address. This 3 dots, copy the address, come here, put it here, and enter the amount and select confirm airdrop. So you'll have some Solana to play around with because you may need to deploy, but that is not needed for now. So coming back here, it gives you a small program where some boilerplate code, and it's what we are going to use. So I want to do some sort of cleanup for you guys. So let's first go delete this and delete everything in the account system. I think we are good to go. Maybe we'll leave the initialize there. Okay, so delete everything down here. I don't want it to scream to me. And yes, so here you put here the account address. This is the equivalent to what the Ethereum address will look like. So I press build and it has pre-filled for me. Cool. So I think it's time now we can start building our small program. So like we said, everything in Solana is an account. Everything in Solana is an account. And the best way you could approach this is, I think, to do it in a strategical point of view. And for me, the way I think about it is I do it in steps. So the first step is handling state. So handling state, or you may call it state management, and then maybe in Solana it's like the accounting system. Okay, so accounting system. That is step number 1. And then step number 2 will do the CRUD system, the functions, the CRUD functions and functions which will do changing state, and then maybe mutating the accounts, changing so. And maybe the next step will do deployment, or we'll do testing. Maybe we'll do some sort of testing, and then the last part will be deploying. So this is my roadmap. That's my roadmap. So step number 1, we are going to first deal with how we can handle state. So like we said, taking back, we say that everything in Solana is an account and it reflects in their development. So I know very well for my program called Heroes, actually you need to change this to match what our program is. So with that, so my program is called Heroes. What do I want? So the functionality of this program is very simple. I want to be able to add a hero, maybe their info, with name, maybe age, maybe their universe, and I mean, like, are they an Avenger, are they Justice League, maybe you have that, and then we'll have the basic CRUD. Very simple. We can create, we can delete, maybe we can change the hero name, maybe we can move them to another universe. Yes, so that is the basic functionality. And I know to achieve this, I'll have to have an account for a hero. So the way you can create a hero account, so I'll add here. So the way you can create a hero account, maybe I'll write here my hero account info. So the way you can create a hero account, you use this, what they call these attributes. So Rust has what this stuff called attributes. What attributes are? I think of them as what the decorators are in Python. Is they help you to handle a lot of boilerplate code. So for example, if you want to set up and want to see how the information is going to retain that repetitive code for an account, you just add this attribute, and all the functionality will be added automatically for you. And that is the beauty with Anchor. Is you do not have to write a lot of lines to get what you want. Just adding that line is enough. So we are going to write a struct, and that structure is for our hero. So we didn't cover structures, but structures are very, very similar to types in TypeScript. They give you some skeleton and architecture of what you want, of how you want to model your data. In our example, in our case here, we have the structure, we have the hero structure, and you know the hero structure will have a hero name, which is going to be of the type string. We have their age. Their age is going to be maybe an I32, and then maybe we have a bio, small bio to have a small description, and then maybe we will keep track of the dates they are created. So, and you know that time is going to be stored as that very nice I64 for integer. So this is a structure, and this is an account. So you will notice that a lot of these Solana programs, everything will have this small account. If it was a song, for example, a song, and then maybe you're building some sort of Spotify, you'll have a struct called a song, and then it will have a song name, it will have a song, maybe a song description, and all of that. So accounts will always be stated there. And then the cool thing about that is all of these accounts, they are all living inside this giant program. Remember this image? So everything is structured inside here, and it is a child to the parent. So structuring our account structure for the hero. Now we have to understand, because we want to create a rent exempt account. Remember we talked about rent where we want to put there enough Solana that it can cover 2 years, and then it becomes a rent exempt, because what Solana wants to see is, does that account have enough money, and then it will forgive you. It's like proof of, hey, that guy is rich, he will be able to pay rent. However much it won't be collected. So we want to calculate and know the enough money that will allow us to like the enough money we will have to put in that account. So you can see and analyze the amount of Solana you'll need to have for a certain sized account. And in the terminal they have this very nice command called Solana rent. And when you press Solana rent and put maybe the size of your account in bytes, so for example, I'm trying to test if my account is 4 kilobytes, and when I press that, it's going to analyze and tell me, hey, this is what you need to put for your account to be rent exempt. So you can always run that program. But the funny thing is, we do not know how much, how the size of hero is what we are going to try to see. So the common way that I see people do it, and I think the way you should think about that, is to separate this into constants, because you may want it to be reusable. So we want to calculate the size of hero, and the way you can calculate it is to calculate the size of every field here. Every field here, you need to calculate the size of every field, and then you sum them up, and then you know the size of hero. So every program, every account that is stored on the Solana blockchain, maybe let me try to show you. I don't know if you guys remember our memory topic that we had in Rust. If you guys remember that, I think you'll be very, very familiar with what we are going to cover here. So if this is what heroes look like, for example, this is our hero account. This is what our hero account, and our hero account is going to cover this available space. So the first thing that you need to know, that you don't have to forget, is that every account is going to automatically have an 8-byte discriminator added to it by default. So I'm trying to calculate the space here visually. So if you guys are, I hope you can follow. So every new account that you create on Solana automatically is going to have a small, is going to add, an 8-byte is going to be added in front of it. And what this 8-byte space system does is to help Solana differentiate it from other accounts. So think of it as the private key. So I would think of it as, this is where the private key that Solana is going to inject in your account is going to live. So this is going to be added by default. And if you're trying to calculate your space, your Solana space, don't forget about that. So I do not know how I can change the color of this. Oh, okay, so beautiful. So yes, so think about this. So this is where our 8-byte, the default, where the private key, Solana is going to put their private key. So it's called a discriminator. So it's called a discriminator. And yes, this discriminator is 8 bytes. So always keep note of that. So I want to put this in separate variables so that I can always come back to that. So maybe I'll have here a comment and I'll say these are constants to calculate the size of hero account. So the first constant that we are going to do is this discriminator. So I'll say discriminator length, and I've seen people call it length. So it is of a type usize. So in Rust they have this default type called usize, and we know that it is of 8 bytes. So now we start calculating these other fields. So the next field that we have is the name. So I would refer you to go to the Anchor documentation to see what this size look like. So if you go to Anchor, the Anchor documentation, there is this, and then you scroll down to the bottom end. There's this very nice tab that has space reference. So it will always show you the type. It shows you here the boolean takes 1 byte, the I64 takes 4 bytes, and the string takes this kind of bytes. So you can always come here and calculate the sizes using the documentation. So let's try to calculate that with us. So the next step, the next size that we have on heroes is the name. So okay, so maybe we'll call it max name length, because the fact that we want to know the maximum size of information that a user can carry. So if you come from the database world, we'll have to have maybe a maximum character limit. So here we want to be the maximum length of a name that a hero will have is 50 letters. So maybe because Batman, someone like Batman, maybe Clark Kent, you know, it will not go beyond 50. So we know that the maximum is 50, and then when you know that the maximum is 50, you come and calculate the space. So the space, we know here in the documentation, it tells you a string covers 4 plus the length strings in bytes. So each single character in a string is 4 bytes. So that means here, if someone has a name of 50 characters, that means it will take 50 times 4. Yeah, so we know here it will be 50 times 4, and then that is the maximum size of the string. And then the next thing that we have is the age. So I'll come again and write another constant, and then we have age. call it age length, keep it very simple, which is of a U size, and then let's go back to the documentation. We know that age is I32, we know it's an integer, and in our documentation it tells you that everything in I32 undefined integer or an integer is 4 bytes. So we know that age is very simple, it's going to be stored on the stack, so it's 4 bytes. So we come back to the bio. The bio is another string, so we shall say maximum bio length. So get that of U size, and now we want the maximum bio length to be something like maybe 240 characters of Twitter. So we say the maximum is 240. So 240 times the 4 bytes of each string is that. So maybe I'll come and do 240 times 4 bytes, which is there, and then we know that the timestamp, so I'll call it constant timestamp length is also of a U size, and we know that is an I64. When I come back here, I look at the I64 is already 8. So beautiful. So we know we have the constants. I don't think we covered constants in Rust. Yeah, but Rust also has constants, and they are very strict as what you think about in TypeScript and the Java world. It's similar. It's a constant variable. It's not going to change. And we know that the size of this information is not also going to change. So that's why we put it in a constant. So we also need to okay, this is me looking at the time. I think we have a very good schedule. So we also need to calculate the length of the full account. What does the full account look like? So I think we did not cover implementations. So every structure that you create in Rust, you can have associated functions which are implementations, like functions that are tied onto the struct, that define the struct, so that you have the whole blueprint ready. These are behavior changes, and I think people from the object-oriented world will call them inheritance stuff. So it is something similar to that. And the way you can define implementations in Rust, maybe I'll add a comment here, and I'll say add an implementation to find the total size of the hero account. Cool. So the way you can define an implementation, you use the IMPL keyword, and then you enter the name of the structure. So our structure is hero, and every function that you write here is going to be tied upon the hero. So maybe let's say I want to, I know we're not going to do this, but just to give you a small example, if I want to change the hero, maybe a hero name, maybe to add create a hero, I'll come here and write fn create, maybe I'll call it new, and then maybe it'll take in the name, which is a string, and then it'll take in maybe age, which is an I32, and then maybe it will have a bio, which will have string, beautiful, and then it will have maybe created that we have it dynamically. So maybe when you have that, and then you can come here and create a new hero, and then you have name, and then you have age, and then you have bio. So it will always work as an associated function. And then there are also other functions that you can write here, where you have, maybe you want to return the name. Maybe I'll say get name. Usually it takes a self. For example, there is the self, and I don't know why the linter is auto-completing for me. So here we have the self, and then it will have maybe you return everything. So this self is tightly tied upon onto the structure. Cool. So we are not going to do that. We will create the functions. Like there's a way Anchor allows you to do that. So we're not going to do that, but just to show you how implementations work. So here our implementation for now is going to do a very simple thing. It's going to create the total length of the hero structure, the total size of it. So the cool thing about that, you can also have variables stated inside the implementation, and that variable will always be tied upon the structure. It's not just type, it's not just functions. You can have enumerations inside here, everything you can put there. So currently we want to just have the total size of the hero account. So we'll call it, maybe we'll also have it as a constant, and we'll call it len, maybe the len, and we'll have it as a usize. And what it's going to do is going to calculate everything that we have here. So starting from the discriminator, remember we said the discriminator length is added at the beginning. Oh, I think I forgot about my visuals. Let me first come back to my visuals. So we said the discriminator state is the first thing that Solana is going to inject. Our next size portion is going to be the name. So what will happen is, maybe I should copy this. What will happen is something like this. So our string, which is the name, so the name will come and take this size. So it's quite big. So it will take something, we said it's 50 times 4, and it will take maybe something like this. This is our name, and then after our name we have another field here, which is age. Age is very small, something like this, maybe age is 4 bytes. It won't take a lot, so it could be that size. And then we have the bio. The bio is a very big field, so it has long text and stuff, so maybe it will come and take the whole of this. And this is the bio, and it's so the size is 240 times 4, and maybe it takes the whole of the remaining stuff. And then we have the timestamp. Maybe the timestamp will come and take something like this here. So when you calculate, this is what happens in the background when your whole program. So I have here as the timestamp. So timestamp is 8. So I presume the timestamp will be equal to what the discriminator is, because they look identical. So the timestamp will look like this, and then you'll have to calculate the whole of this size, and then when you have the total of everything, it will be the rent of your program. So it's the total of everything. This will be the rate of the program, and this will always keep on growing. Maybe if we create a few fields and add there, this will be added there. And then maybe if you create another account, maybe you call it universe, and then you have to calculate the total of everything, and then you batch them together, and you have the whole total account there. But you may not, the moment you have Anchor will help you to calculate for you the information and the prices. Only that you have to help it and point it out for you. Yeah. So going back to this, we will have to add the discriminator size, and then we have to have the max name length, and then we have to have the max age. I think it's called age length. So I'm used to Vim. I came up with a very funny command, not forgetting that I'm not in VS Code. So after then the bio, and then we have the timestamp length, and then terminate. So every associated function that is going to be tied upon the hero is going to be defined inside here. Cool. So we know the size of our hero account. Maybe I think I'll leave it here. So we know the size of our hero account. We've calculated the length. We calculated the size, and we put it in an implementation. So this is the first part. So we've done the first part of handling state. So if I come here, maybe I'll have a small check mark. I don't know if the IDE will allow me to do that. So we have the check mark. We've done that. So the next function is going to be CRUD functions, and this is something that I don't want to cover now because I want to do it in a very small step where we do a small milestone, and then the next day we'll do another functionality. So the state management has been done. So I want to do the CRUD function and mutating and changing state tomorrow. Hopefully, I don't know, Vianney, if that's on your schedule too. And yeah, so I'm open to all questions if you guys have any. Okay, if you guys don't have any questions, I want to end this at that. Tomorrow I want to cover the CRUD function, handling state and mutating state, and hopefully the goal was to do that. And then I think tomorrow is Thursday. On Friday we'll do some sort of testing. We'll write some script to test the information, the smart contract, and then I don't know if Vianney, it will be okay with you. We will have to have some sort of UI. I want to connect to a small UI where you guys can see everything being pieced together. So we may have something extra maybe for the people that want to do the front end, but this is just tied to the blockchain stuff. The UI will come as a bonus maybe if for the person that wants to see the full stack. Yeah, but yeah, hopefully we'll get to that. So Vianney, I'm going to move the mic over to you. If you are still with me, yes. So I think we do not have Vianney, and we looks like we do not have any questions up front. So yes, so hopefully this repo is going to be, I'm going to share with you guys this code. It's going to be updated in the repo. For anyone that wants to play around with the repo, it's going to be shared in the Decentraland socials. With the updated code, that everything that we are pushing is going to be there in the repo. Yes, Vianney.
Yes, I think it's been a great walkthrough. Personally, many of the things I'm learning them, I stopped somewhere. Then I just started watching, but I'm going to be catching up also with the repo, and yes, and also I will rewatch. Actually, I always rewatch so that. Yeah.
Yes. Also, this is going to be uploaded on YouTube, and the content will be there. Yeah. So we'll stick around and maybe, yeah.
Come to Alibaba.com for sports and entertainment. I think. we can conclude.
You have no questions?
I have no questions.
Cool.
Thank you. I think
Alright, guys, thank you so much. Yeah.
Each and every one of you is doing splendid. It's a fine evening in Nairobi.